Hi, and welcome to this video clip where I'm going to go over double replacement reactions at a little bit higher level than a simple introductory level that might occur in 10th grade or 11th grade chemistry. So let's take a look at this. Quick reminder, for double replacement to occur, we have two ionic compounds and or acids and or bases, okay, that are reacting. These are not redox reactions. So oxidation numbers will remain unchanged. There is no exchange of electrons. I'm going to, as reactants, one or both will be soluble, but you could actually end up with two insoluble products there. I don't know why I X'd that out. So here, one or both will typically be solid in terms of the reactants. But as products, it is possible to get two precipitates forming. Not likely, but it is possible. We'll see one example where you'll see that neither of them can be dissociated. Neither of the products can be dissociated. Our driving forces are the formation of a solid, a gas, or water. Okay, so let's take a look at this. Silver nitrate, solutions of silver nitrate, aqueous, plus sodium chromate. Hope you know those polyatomic ions are mixed. This is when I think it's helpful to put the charges underneath, but you do need to erase them when you're done, so you won't lose points on that. +1 silver is going to react with the -2 chromate, so I'm going to get silver chromate formed. Follow your formula writing rules, and that's a solid. And then I'm going to get sodium nitrate, and that's aqueous. And we do need to balance, don't forget that. Okay. Now to do the complete ionic, if it is a soluble salt, strong acid, or strong base, I'm going to separate it into cations and anions. I'm going to not put states here just because it gets a little bit messy, but you really would want to bring those states down. Okay, sodium ion is my cation, and I have two of them, and they're swimming away. They're now surrounded separately by water. It's what happens with aqueous is water surrounds your ions, and the chromate ion. Do not dissociate your solids, gases, and liquids. So I'm going to keep that together, and in fact, sometimes I really like to keep that state there as a reminder to myself, don't dissociate your solids. Okay, anything that remains unchanged from reactant to product is a spectator ion. So in our case, the sodium ion and the nitrate ions were unchanged. So to zero in on the interesting chemistry, we would have silver ion plus chromate ion to give us that solid silver chromate precipitate. Okay, what that tells me is I could have brought silver along with, let's say, perchlorate ion, or I could have brought the chromate in with potassium. That wouldn't have made much of a difference in terms of the interesting chemistry. That's what that net ionic is. Okay, let's try another one that's a little unique that you might not see in an entry level. This time we have two products that can't be dissociated. So I have sulfuric acid plus barium acetate solution. We're assuming solution there. Okay, so that's +1 - 2, +2 - 1. So that means our +1 and the acid is going to go with our -1 of that salt, and I'm going to make HC2H3O2. All right, and that's aqueous, it's an acid, and then I'm going to get barium sulfate. And if you look up your sulfate solubility rules, you'll see that that forms a solid precipitate. Now, just a heads up, if you are in AP, you're not expected to do that much predicting anymore. You definitely have to know how to write net ionics. In terms of the predicting, there would be some sort of data to help you get to the product, and they're less interested in you memorizing prediction patterns than they are you understanding the underlying chemistry. Okay, the first H plus of sulfuric acid is strong, so I like to write it this way. All acetate salts are soluble without exception. So you notice I'll get 2 acetate ions, each separately surrounded by water. Acetic acid is a weak acid, and so we're not going to dissociate our weak acids. Those don't dissociate to any great extent. And we've got to keep our solid together. And there are no spectator ions, and our complete ionic is also our net ionic in this case. So that is probably the most complicated type of thing you're going to see in your double replacement reactions. So hopefully that gives you an indicator of what's going on. We're going to be doing decomposition in another video, but just a heads up, sometimes, let's say you formed, I don't know, a calcium carbonate. Okay, sometimes in a net ionic reaction, let's say, and you form sodium chloride, sometimes if this is heated, this can decompose. So every once in a while, you might see a little bit of a gas showing up when it's a double replacement reaction because it's followed by a decomp. And I'll talk more about that later on. Calcium carbonate wouldn't decompose too much if there was water present, but that is a possibility if the conditions are right. So you want to keep an eye on that if you're given data to warrant that secondary reaction that occurs. So, okay, thanks for joining me. I hope I'm helping you on your journey of chemistry.